this is the second way we can determine the rate law. The first way to determine the rate law is by looking at the mechanism and writing the rate law from the slow step of the mechanism. The second way you can determine a rate law is empirically, by looking at experimental data and deducing how each of the reactants influences the rate law. Now, let's analyze this experimental data here. We have several different trials, and for each trial, the concentration of one of the reactants was changed. So if we look at trial 1 and trial 2, the concentration of A stayed constant, and the concentration of B is doubled. Therefore, any change in reaction rate must have been caused by the change in the concentration of B. Because the concentration of A stayed constant, any change in the reaction rate must be caused by the change in reactant B. So reactant B was doubled, and the rate law quadrupled. That tells us that the rate must have something to do with reactant B squared. Now let's talk about that again. Reactant A was held constant, while reactant B's concentration was doubled. When reactant B's concentration was doubled, the rate law quadrupled. So that means that our B term must be squared, because when B was doubled, increased by a factor of 2, our reaction rate increased by a factor of 4. The only way 2 will equal 4 is if 2 is squared. But that's not the whole story. We have to analyze A. Now, in looking at trials 2 and 3, B was held constant there, while reactant A was doubled. When A was doubled, the reaction rate was also doubled about. So when A doubled, the reaction rate increased proportionally. That tells us that in the rate law, A is present to the first power. For every increase in A, the rate will increase proportionally. And just one other small note, it doesn't matter the order here. Probably see it in the order that the reactants are listed in the overall reaction. You'd probably see it like this, but it doesn't matter. I just listed it like this because of the way the data was presented in the table. But this and this are both completely valid and completely the same thing. Let's practice. So pause the video here and try to deduce the rate law from this experimental data. Below is the rate law as determined from this experimental data. You could have given either rate law. Rate is equal to K times the concentration of A raised to the 0th power times the concentration of B raised to the first power. So we deduced A's power by noting that when B was held constant and the concentration of A changed, nothing happened to the reaction rate. So for this particular reaction, the concentration of A does not impact the reaction rate. The amount of A does not change the rate of the reaction. So A is raised to the 0th power or is just not there. Anything raised to the 0th power is 1, so it effectively eliminates A from the rate law. So you can write it like this or like this. And then looking at B, we saw that when A was changed, but again, it doesn't matter that A was changed because A won't change the rate law as we already found. When B was doubled over here, the initial rate was doubled. And then again, when B was tripled, going from 0.2 to 0.6, the rate also tripled. So from this data, we can conclude that B is raised to 1 additional point about determining about the rate law specifically is orders of reaction. An order of reaction is simply the exponent to which that reactant is raised. So we would say that the order of this reaction with respect to A is 0, because A is raised to the 0th power. And we would say that the order of this reaction with respect to B is 1, because B is raised to the 1st power. Then the only other thing we can say is that the overall order of the reaction is equal to the sum of all of the exponents. So here, the overall order of the reaction would be 1, because 0 plus 1 equals 1. Flipping back here, what would be the order, what would be the order of the reaction with respect to B? Very good, it is 2. What would be the order of the reaction with respect to A? 1, beautiful. And what would be the overall order of this reaction? Exactly, 3, 2 plus 1.